Physical safety and environmental controls. So physical safety, this one's kind of a no-brainer. But the number one injury for us IT types is lifting heavy stuff. And no, it's not because we're weak and little nerds. It's because we lift wrong, right? So you don't want to lift anything over 25% of your own weight. If it's heavy, you're going to need somebody to help you, right? Now, I know this seems kind of silly because you're like, I can lift a computer. Computers aren't that heavy, right? Because they're not. But have you lifted a server before? I have. They're heavy. Have you lifted a battery backup before for a server? They're really heavy, like 150 pounds, 200 pounds heavy. So make sure dual lift many, many people. And again, lift with your legs, not with your back, okay? Don't open up things that can hurt you, right? So we talked about this in the last lesson about power supplies, right? That's the inside of a power supply. See these big cylinders here? Right here? Those are the capacitors. Those are the things that hold lots and lots of voltage that if you touch will kill you or hurt you really, really badly. So don't touch those. And again, there's no reason to take these apart. They cost so little, it's just a disposable part for us. It's not worth trying to save them. Lots of parts of our computer become hot when we use them. When power comes in, it's coming in as volts AC, right? We talked about that, 120 volts AC. What this power supply is actually doing, we'll talk about this more in power supply lectures, it's converting it into direct current, DC. And it's taking it from 120 volts AC and putting it out in 3.3, 5, or 12 volts DC. That power change is a transformation that's happening here. It's a transformer, and that creates a lot of heat. So if you've ever put your hand behind the back of your power supply on the computer, you feel all that heat coming out, it gets hot, right? So if you went and touched the metal on the inside, it would burn your hands. So don't do that. Laser printers, the fusers in there, they are going very, very hot so that they can basically melt toner onto the paper. So if I just printed out like 100 pages and now it jammed and you want to go fix it, be careful because if you touch that hot fuser, you're going to burn your hand, right? Power supplies, again, they become very hot. CPUs as well. That little chip in there that's doing all the processing, it's doing it at 2 or 3 gigahertz, which is like billions of times a second. It's flipping these electricity bits. That creates heat. That's why we have cooling. We have heat sinks and we have cooling fans on top that we draw that heat away from it. But if you go to replace that chip right after you were running the computer, it's going to burn your hand. So it's just like your car. You wouldn't go work on your engine after driving to the mechanic. They're going to let it sit there for an hour and then work on your car because they need to cool down first. Cable management. You always want to route your cables so they don't interfere with walkways or normal activity of employees, right? In this room, I wouldn't put a cable between Nick and Joseph because then when I go out to go to the restroom, I'm going to trip over it and fall. Makes sense, right? Yeah, and you got to make sure people know where these things are. If you look around the room, we have all the cable management done really nicely, right? We run all the cables through the desks, over to the wall, through these raceways, and so there's nothing on the floor for you to trip over, right? Because we don't want an incident. You also want to make sure your computer, the cables are actually nice behind the computer. How many times have you guys gone in and seen one of those nice big wooden desks that executives like, right? You know, the senior guys, they can't have an open desk like this. They got to have the nice big desk. And what do they do with the computer? They shove it in the back corner up against the wood. And so all that heat that's getting pushed out of the back of the computer is going where? Between the computer and the wood, and it's trapped. And then it overheats the computer. So you got to make sure there's good airflow. Make sure you have that computer in a place that you have airflow that goes through. And if you're installing new network cables, you got to make sure you're doing it per code. A lot of places have certain codes, just like the electrical codes, how you run wires. They'll do the same thing with computer networks now. And so you have to have professionals install it. I believe Maryland is one of those. You have to have like the actual licensed person install those cables, especially when they're going through your walls. When they're going along the sides here where you can visibly see them, that's not an issue. But a lot of electricians actually run network cables as well now, phones and network cables. Physical safety. Why is cable management important? Because you don't want it to look like this. This is a beautiful picture of power overseas. Remember I talked about dirty power? That's why. On the right is not much better. That's a server room. That is not how it should look either, right? That is a death trap. It says, do not unplug the wires, right? Oh, do not touch any of these wires. Yeah. So when somebody has a problem, is it going to be easy to figure out why their computer network drop's not working right? Probably not, right? So yeah, from an organizational standpoint, it's a nightmare. Additionally, this bundle of wires is blocking lots of airflow. Those routers and switches can overheat. If they overheat, they can break. If they break, lots of the network's going down. So we want to make sure this stuff is done properly. What should it look like? It should look nice and clean, more like that. So environmental controls. Our server room environments, we have environmental control sensors all over them. We want to make sure that we have temperature, humidity, and air set properly. For us, for temperature, it should be between 68 and 76 degrees Fahrenheit, with about 20 to 60% humidity. So I always like to say San Diego weather, right? It's beautiful. And that's what our server rooms are like. We keep them at 68 to 76 degrees, which is nice, but a little chilly for us as humans, right? So we're usually going to wear a jacket to work even in the summer. High humidity is bad. If you have high humidity is good from the standpoint of there's less electrostatic buildup, which is a good thing. We don't want electrostatic buildup because electrostatic is when you ever like shock yourself in the wintertime? That's electrostatic buildup, right? Where you took a balloon and rubbed it on your head and had your hair pull up by the balloon. It's electrostatic electricity, right? That's bad for computers. So high humidity is good from that standpoint, but high humidity means high moisture. Is moisture in electronics good? No. So it's bad for that too. So that's why we try to keep it right in that middle range of 20 to 60% humidity, right? And we have systems in place that do that for us. Also, we want to make sure we have proper ventilation. We need to have proper ventilation to keep the computers cool. We also need proper ventilation to make sure that you're breathing successfully, right? If we have stale air, you start choking on it, right? And when you're blowing out dust from a computer or a vacuum, do it outside. You guys all seen the compressed air, right? How many times have I seen people go, hey, let me fix this computer, and you open it up and there's cat hair and dirt and everything else in it. Like, oh, I'll just blow this out. And they just blew all that dirt all over the customer's house, right? Take the computer outside, blow it out, then bring it back in. Just another customer service thing that makes sense, right? But again, why do we need to blow out all that dust and dirt? Because it's blocking and restricting airflow as well. If you have a lot of dust and dirt, it's blocking all that airflow. The computer's going to overheat, and you can have more problems. MSDS, Material Safety Data Sheet. If you see MSDS on the test, they're talking about chemical data sheets is essentially what we're talking about. Okay? If you worked any place, they have MSDS for every chemical in the building. Any product that has chemicals, including Windex, will have an MSDS on file at the company you're working at. It says things like the proper treatment if the person comes in contact with the substance. So if I spill some Windex on my hand, what should I do? Should I wash it off or should I call poison control? The MSDS will tell you that. What if I spill it on the floor? How am I supposed to clean it up? How do I dispose of it when I'm done with it? Can I just throw it in the trash can or do I have to take it to the local recycling plant? What is the proper storage? Can I just leave it on the counter or do I have to put it in a flammable locker? All those type of things will be inside of an MSDS. So here's just an example here. We have the super clean detergent, and you can see it identifies the product, tells you what's in it, tells you the characteristics, tells you about fire and explosion, and as you go through it, would tell you all this other information as well. Basically on the test, you'll probably see one question on MSDS. And if you just remember, MSDS is the Material Safety Data Sheet. It's how to deal with products that have chemicals in it. Some of the things we deal with in computers have chemicals in it. For instance, when we use the liquid cooling system, yeah, there's chemicals inside the liquid cooling because it's not just water they're using in there. I was thinking of, thermal paste. That's what I was thinking of. When we put the processor in, we put this paste on it first, and then we put the heat sink on top. That paste is chemical-based, and so there is MSDS requirements for that as well. Okay. Disposal. How do we get rid of stuff? Well, some items have to be disposed of when they're old, right? And they break. This old monitor probably needs to get thrown away, right? Because I don't think anyone wants to use this monitor at home anymore, right? You all like the nice LCD monitors. When you throw this away, you got to be careful, though, because inside of these has 10 to 20,000 volts because they use capacitors as well, just like those power supplies do, okay? So we don't want to open these up and work on the insides of them unless you're a qualified person, just like old TVs. There were TV repairmen for a reason because these are dangerous, right? Again, these aren't worth fixing. Just throw them away, right? But you can't just throw it in the trash can. You got to take them to the recycling place. In Anne Arundel County, there's actually at the dump, you take them there and they'll take it from you, okay? You can't just throw it in the dumpster. Some items may contain chemicals or other dangerous items that must be disposed of in accordance with the local regulations. Like I said, here in Anne Arundel County, if you take it over to the Millersville dump, they'll take it from you and recycle it for you. Here are 3 questions. I upped the game on you. All right. First question. A user wants to dispose of a CRT monitor that's no longer working. Which of the following steps should the technician complete before proceeding with the disposal? Should they break the glass in the CRT in a controlled environment to prevent injury? Should they discharge all the capacitors in the CRT and remove them before disposal? Should they ensure familiarity and compliance with local regulations? Or should they ensure the monitor is no longer working and repair it if possible? C, right? Local regulations, right? We're not going to repair it. They're too old, not worth it. We're definitely not going to break the glass because we might hit those capacitors and it's just going to make a big mess. And we don't want to discharge capacitors because we don't want to hurt ourselves. So yeah, C. So a technician is giving a safety class to the new employees. Which of the following contains dangerous voltages and should be handled with care, even if the power has been disconnected? The laser printer, the wireless router, the paper shredder, or the CRT? D, the CRT, exactly. And the last one. Anne is a user, one of our famous users that loves to help us out all the time, and she has moved the orientation of her desk to arrange the power, and she now needs to arrange the power and network cables to suit it, because she wants to be over by the window and not by the door, right? So she can't just run them along the baseboard, so they're going to go right across the middle of the room. Which way would be the safest and most practical approach to moving her desk? Should we just get a throw rug and throw it over the cables? Should we use a rubberized floor cord cover? Should we secure it with ISO-compliant duct tape? Or should we install a raised floor system? B, we should use a rubberized floor cord cover. All right, so what a raised floor system is, if you're not familiar with this, a lot of buildings will use this now. It's basically the floor will have a raised tile system and you can pick up the tile and run the cables underneath it. We use this a lot in government facilities. And it's great for computers and relocating stuff because then we can just pick the tile up, put the cables under the floor, pull up the tile over here and bring it back out. But the reason why it's not the answer here is because you're not going to install an entire raised floor system for one user. It's very expensive, right? So the most practical is this rubber cord cover. The throw rug's bad because it'll slip and move, and I'm not sure what ISO-compliant duct tape is, but still duct taping it to the floor is not in regards to OSHA regulations either. So rubberized floor cover is the way to go.